It's amazing when you think about it, right? Like, how much of our lives these days, I mean, pretty much everything we do online, it all comes down to data.
Oh, absolutely. Yeah.
Every app, every website, everything's creating it, storing it, using it constantly.
It really is.
And behind so much of that, there's this kind of quiet powerhouse, and that's SQL.
Yeah, it's like it's the infrastructure you don't see,
Right.
but it's everything relies on it.
Totally.
SQL, structured query language, it's really the foundational language for managing, I'd say, the vast majority of the relational databases that make our digital world work.
So that's what we're going to do in this deep dive. We are going to get under the hood of what SQL is, what relational databases are, and really some of the core ways that we use SQL to work with data.
That's it.
And the idea is to give you a clear picture of these essential concepts without, making it too technical, hopefully.
Yeah, we want to make it digestible.
Exactly.
We've got some great material here that breaks it down. We'll be looking at, like you said, what is SQL, how a relational database is structured, and then what are those kind of basic SQL commands that make it all happen.
Perfect. So let's just get right into it. What is SQL?
So SQL, at its heart, it's a domain-specific language. And what that means is it's like, think of a chef.
Okay.
A chef uses specific tools and techniques for cooking. Well, SQL is the specific tool or the language we use when we're working with databases that are designed to store and connect data in effective ways. And these are what we call relational databases.
So it's a language just for talking to these data storage systems.
This is a great way to put it.
Okay. And, I see it over and over that SQL supports what are called CRU operations.
Yeah.
What is that?
CRUD is a really helpful acronym to remember
Okay.
because it really encompasses the fundamental things you can do with data. So CRD stands for create, read, update, and delete. And these are the 4 basic actions that you perform on data in pretty much any application. So you need to be able to create new records. You need to be able to read or retrieve existing information.
Right.
You need to be able to update records that need to be changed. And then finally, when data is no longer needed or useful, you need to be able to delete it.
Makes sense.
And so SQL provides the commands to perform all these basic but very important operations.
Okay. So it's basically like it's the instructions that we give to the database about how to handle information.
Yeah.
And it's described as a standardized language.
It is.
Why is that so important?
The standardization of SQL is one of the things that makes it so powerful.
Okay.
What it means is that it's not tied to one particular company or database system. So whilst you have different database systems like MySQL, PostgreSQL, SQL Server, they all have their little, extra features or slight variations. The core SQL language is very much the same across them.
Got it.
And this has huge benefits. I mean, for one thing, as someone learning it,
Right.
it means that once you understand the fundamentals, you can basically work with many different types of relational databases.
It's not like learning, French and then having to learn Spanish.
Exactly. It creates this common ground for how you define data, how you manipulate data, and how you ask questions of that data, regardless of the actual system you're using. And it also means there's a massive community of developers, a really wide range of tools, all speaking the same language.
It's kind of like a universal remote.
Yes.
That works with, Samsung, LG, whatever.
That's a great analogy, yeah.
Okay. So in the real world, what are some things that you can actually do with SQL?
So the applications of SQL are really broad. And as we touched on with CRD, you can retrieve very specific information that you need. So for example, if you're a business, finding all the customers who signed up last month.
Got it.
You can update existing information. So, changing a user's password or adjusting the inventory levels of a product.
Okay.
And then crucially, you can also manage the entire structure of the database itself.
Okay.
So creating new tables to hold different kinds of data as your needs evolve. And these simple actions like create, read, update, delete, they really form the bedrock of how almost every application interacts with its data.
So SQL is the language that we use to give the instructions.
Yeah.
So let's talk about now what a relational database is.
Okay.
What does that even mean?
So a relational database is a way of organizing data in what we call tables. And you can think of a table like a spreadsheet, a well-organized spreadsheet. It's made up of rows and columns.
Okay.
Each row in a table represents a single unique record.
Okay.
So for example, all the details about one specific product in an online store, and each column represents a specific attribute or piece of information about that record. So the product's name, its price, its description, and so on.
So I could have one table that's like all my products.
Yeah.
Another table that's all my customers.
Exactly.
And then is that where the relational part comes in?
That's exactly where the relational aspect comes in. So instead of having this giant table with everything crammed in,
Right.
relational databases allow you to establish clear relationships between these different tables. And this linking is done using what we call primary and foreign keys.
Okay.
And this is powerful because it helps to reduce redundancy
I
and improve the consistency and integrity of your data overall.
Okay, so let's break those down. What is a primary key?
So a primary key is like a unique identification tag for every single row within a table.
Okay.
It's a column, or sometimes it could be a combination of columns, but its value uniquely identifies every single record. Think of it like a fingerprint.
Okay.
Each row has its own unique fingerprint. It cannot be empty.
Got it.
So for example, in our products table, the product ID would likely be the primary key.
Okay.
So each product has its own distinct ID number that sets it apart from all the others.
So it's the one thing that makes it special.
Exactly. It ensures that every product record is uniquely identifiable, prevents confusion or duplication.
And then the foreign key is how we make the different tables connect and talk to each other.
Exactly. A foreign key is a column in one table that references the primary key of another table. It acts as this link between the two.
Okay.
So the values in the foreign key column of one table must correspond to an existing value in the primary key column of the other table.
Got it.
And this is how we formally establish these relationships.
Do you have an example to kind of make that make sense?
Yeah, absolutely. So let's imagine we're back in our online bookstore.
Okay.
And we have our books table.
Okay.
And each book has a unique book ID as its primary key.
Got it.
Now, every book has a publisher.
Right.
So in the books table, we might also have a column called publisher ID.
Okay.
And this publisher ID would be a foreign key that references the publisher ID, which is the primary key, in a separate publishers table.
So the publisher ID in the books table is pointing to a publisher in the publishers table.
Exactly. So this way, for every book in your books table, the publisher ID points to a specific, valid publisher in the publishers table.
It's like it's a pointer.
Yes, it's a pointer. This connection allows you to easily find out, okay, which publisher produced this particular book.
Right.
Or conversely, list all the books published by this particular publisher.
Got it.
And it ensures that, you don't have books listed with publishers that don't actually exist in your publishers table.
That makes perfect sense. It really clarifies why it's called a relational database.
Precisely. And this structured relational approach is key to avoiding duplication and making it much more efficient to manage and query all this related information across all these different categories.
Okay, so now we get to the fun part,
Okay.
which is the basic SQL commands.
Yeah, these are the instructions that we as users give to the database
Right.
to work with this structured data.
Yeah, and I think these are really interesting. So the core commands that we need to know to get started are create table, insert, select, update, and delete.
That's it. You got it. Those are the verbs of the SQL language.
Okay, so create table, that one's pretty straightforward.
Yeah, it does what it says on the tin.
Okay.
You're defining a brand new table within your database. So when you use create table, you're basically saying, okay, what's the name of this table I want to create?
Right.
And then you define all the columns that will exist in that table. And for each column, you specify its name, what type of data it will hold. So will it be text? Will it be a number? Will it be a date?
Okay.
And then also any constraints. So which column is going to be the primary key that uniquely identifies each row?
Got it.
And the example we have here is to create a customers table.
Okay.
So the command is create table customers, and then in parentheses, customer ID, INT, primary key, name varchar 100, email varchar 100. So this tells the database, create a table named customers. It's got these three columns, customer ID, which is an integer, and it's the primary key. Then you've got name, which can store up to 100 characters.
Okay.
And then you've got email, which again can store up to 100 characters.
So that sets the foundation.
Yeah, you're defining the blueprint.
We've built a container. How do we put stuff in it?
That is where insert comes in.
Okay.
Insert is used to add new rows of data into an existing table. So you've created the table with create table. Now you use insert to actually populate that table with data.
Got it.
So you specify the table you want to add data to, and then you provide the values that you want to go into each of the columns for that new row. So for example, you might insert a new customer into the customers table by providing their customer ID, their name, and their email address.
Makes sense. And then select must be how we get the data out of the database.
Exactly.
Like if I want to see all the customers in New York.
Yeah. Select is the primary way that you retrieve data from one or more tables, and
Right.
it's super versatile, super powerful. With select, you can specify exactly which columns you want to see. You
Wow.
can filter the rows based on specific conditions using things like the where clause, which we'll come back to.
Okay.
And you can even combine data from multiple tables to get, a really comprehensive view of your information. So anytime you run a search, you're on Amazon, you're searching for a product,
Right.
behind the scenes, that's a select statement.
Got it. Okay, so UP date, I assume that's how we modify data that's already there.
You got it.
So like if a customer moves.
Exactly. UP-date allows you to change the values in existing rows
Okay.
based on certain criteria. So if a customer moves, you'd use an UP-date command to find that specific customer, probably using their customer ID,
Copy it.
and then change the value in the address column. You can update one column. You can update multiple columns.
Right.
But you use the where clause very carefully to make sure you're only changing the rows that you intended to change.
And then lastly, delete.
Yeah.
That's how we get rid of entire records, like a whole row, if a customer closes their account.
Yeah, delete is used to remove one or more rows from a table, again, based on conditions that you specify using that where clause. So if a customer closes their account, you might use delete to remove their entire record from the customer's table.
Got it. And you've got to be careful with that one
Be very careful with delete.
because it's gone.
Always specify your conditions really precisely. You don't want to accidentally delete data that you wanted to keep.
Yeah, that would be bad. Okay, so those are the fundamental commands. The material we looked at also talked about some other key concepts, and a really interesting comparison was between SQL databases and NoSQL databases.
Yeah,
You hear about NoSQL a lot.
you do.
So what is the main difference between SQL and NoSQL and how they approach storing and managing data?
So this is a really important distinction in the world of data.
Okay.
As we've been discussing, SQL databases are relational. They organize data into these structured tables with what we call predefined schemas. So this means that before you even start storing data, you define the structure of your tables, the columns, what data type they are, what are the relationships between those tables.
A very organized way to do it.
It's very organized,
Okay.
very consistent. NoSQL databases, on the other hand, are non-relational. So they offer much more flexibility
Yeah, okay.
in the data models. They don't necessarily require a fixed schema.
Got it.
This allows you to store data in various formats. So you can store data in documents, kind of like JSON. You can store it as key value pairs. You can store it as graphs.
It was much more adaptable.
It is.
I
It can handle different kinds of data without needing that really strict structure.
Yeah.
And this can be really beneficial for handling data that's less structured or that changes really frequently.
Okay, so SQL is more about, I guess, having a rigid structure up front.
Yeah.
And that allows us to have these very specific relationships that we talked about.
Ex-
NoSQL is much more adaptable, it can change, and it can handle different kinds of data more easily.
Yeah. And because of that structured nature in SQL databases, they excel at handling complex queries. So you can ask very specific questions about your data
Right.
and get very precise, reliable answers, especially when that data is all interconnected.
Okay.
And plus, SQL, like we mentioned, is a standard. It's
Right.
got this long history. It's got a vast ecosystem of tools, a huge community, lots of best practices.
Right.
And, NoSQL has its own benefits as well.
Okay.
So that flexibility can be a major advantage in situations where your data requirements are changing rapidly.
Got it.
Or if you're dealing with huge volumes of unstructured data where that rigid schema could become a bottleneck.
So it's really just about picking the right tool for the job.
Exactly. Horses for courses.
You mentioned schema a couple of times.
Yeah.
In the context of SQL, what is a schema?
So a schema in SQL is basically the blueprint of your database.
Right.
It defines all the components.
Okay.
So all the tables that exist in the database, the columns that make up each table, what data type each column is, and crucially, the relationships between those tables, the primary keys, the foreign keys.
Got it.
It dictates how your data is organized, structured, and related within the database.
Okay, it's the blueprint.
Yeah.
And we have a specific example here of how to add a new piece of information, like a new column, to a table that already exists.
Yeah.
Can you walk us through that?
So to modify the structure of an existing table, you'd use the alter table command.
Okay.
So for instance, let's say we realized, we also want to store our customers' phone numbers
Right.
in that customer's table. The command would be alter table customers, ADD, column M phone number varchar 15.
Okay.
So that tells the database to go to the customer's table,
Okay.
add a new column called phone number.
Got it.
And it's going to be a varchar of up to 15 characters.
Okay. Pretty straightforward. The where clause has come up a couple of times.
Yeah.
That seems to be a very fundamental part of SQL.
It's super fundamental to select, update, and delete commands.
Okay.
It acts as this filter. It allows you to specify the conditions for which rows will be affected.
So it's like saying only do this to these.
Exactly. So for instance, if you wanted to select only the customers who live in, say, New York, you would add a where clause to your select statement specifying, where city equals New York. So only the customers in New York would be returned.
Got it.
Similarly, you can use where with update to change the address of a specific customer based on their ID.
Okay.
Or with delete to only remove customers who meet certain criteria.
Okay.
So it allows you to really narrow the scope of your operations.
We also saw the command to delete an entire table.
Yes.
Hopefully that's not something you do every day.
No, you got to be very careful with this one. So the drop table command is used to completely remove a table and all of its data.
Okay.
So the example here was drop table customers.
Okay.
If you ran that command, it would delete the entire customers table, all the customer records, gone.
Go on.
So extreme caution with that one.
And then there was this distinction made between delete, which we talked about, and another command called truncate.
Yeah.
What's the difference there?
So while they both remove data from a table, they do it in very different ways.
Okay.
So as we said, delete removes rows based on the conditions in the where clause.
Right.
And it also logs each deletion, which can be useful for some things like transaction management.
Okay.
Truncate, on the other hand, is much more drastic. It removes all rows
Wow.
from a table.
Okay.
And it does it very quickly because it doesn't log each deletion. It basically just deallocates the storage space used by the table.
Got it.
So it's much faster than delete for removing all rows, but it also means it's less recoverable.
Okay.
So think of delete as carefully picking items out of a box one by one,
Right.
whereas truncate is like just flipping the box over and everything falls out.
Got it. So delete, we have a chance to get things back potentially.
Yeah,
Truncate, it's gone.
it's gone.
Okay. We also encountered this concept of a view in SQL.
Yeah.
What is a view?
So a view is basically like a virtual table.
Okay.
It doesn't actually store any data itself. It's like a saved select query.
Okay.
So when you query a view, the database runs that underlying select statement,
Right.
presents you with the results as if it were a real table. Views can be really helpful
Okay.
for simplifying complex queries that you use a lot,
Got it.
or for providing a specific perspective on your data to different users without letting them see the underlying base tables.
So it's almost like, I don't know, saving a search.
Yeah, that's a good way to put it, yeah.
And then you can just run that search again and again.
Exactly.
Okay. And then renaming a table.
Yeah,
Can you do that?
you can rename tables.
Okay.
You do it with the alter table command again,
Okay.
followed by rename to, and then the new name you want to give the table. So the example was alter table customers rename to clients. So if you run that, your customers table would become the clients table.
So it's pretty straightforward.
It is, yeah.
And then lastly, we encountered these share and varchar data types
Yes.
when defining columns.
Yeah.
What's the difference between those two?
So they're both used to store strings, which is basically text.
Okay.
The key difference is in how they manage storage space.
Okay.
So share are when you define a column with share and specify a length,
Right.
the database always allocates enough space to store a string of exactly that length,
Okay.
even if the string you're storing is shorter.
Yeah.
So if you store a 5-character string in a share 10 column, the database will pad it with spaces to make it 10 characters.
Got it.
Varchar, on the other hand, stands for a variable length character.
Oh,
So it only uses the storage space needed for the actual string that you're storing,
okay.
plus a little bit of overhead to keep track of how long it is.
Got it.
So this makes varchar more efficient for storing text where the length can vary, because you're not wasting space on all this padding.
So varchar is generally a good choice.
Yeah, generally more flexible.
Okay. Now, to bring all this together, we have a great example here, which is the online bookstore database.
Yeah.
So let's revisit that. What were the key tables and how do they relate to each other?
So the online bookstore database, it's a really good example of a typical relational database design.
Okay.
And it has these 4 key tables: books, authors, book authors, and publishers.
Okay.
So the books table would have a book ID as its primary key.
Right.
That's the unique identifier for each book.
Got it.
Then to link a book to its publisher, it also contains a publisher ID column.
Okay.
And that acts as a foreign key referencing the publisher ID, which is the primary key in the publisher's table.
Right.
This is a one-to-many relationship.
Okay.
One publisher can publish many books.
Got it.
The author's table would have an author ID as its primary key.
Okay.
Now, because a book can be written by multiple authors and an author can write multiple books, we have a many-to-many relationship here.
Okay.
And we typically handle this with a separate linking table called book authors.
Okay.
This table would have a book ID and an author ID, both of which are foreign keys.
Okay.
And the combination of book ID and author ID would likely form a composite primary key.
Yeah.
So each pairing of a book and an author is only recorded once.
Got it.
This relational design allows us to manage information about books, authors, publishers,
Right.
and easily see how they're interconnected.
Okay. And then there was this scenario where we wanted to see a list of all of our customers who have not placed an order.
Yeah, the just ones who haven't bought anything yet.
Right.
So the query we used to find that was select customers.name. From customers left join orders on customers. Customer equals orders.customer.ed, where orders.order is in EAL.
Okay, so let's break that down.
Okay, so first it starts by saying we want to select the name column from the customers table.
Got it.
Then we do a left join with the orders table. The on-end clause, customers.customer equals orders.customer.
Right.
That's saying we want to link rows from customers with rows from orders where the customer ID is the same.
Right.
Now, the left join is important because it ensures that all the customers are included, even if they don't have a matching order.
Got it.
And then finally, the where clause, orders.order is MNLL.
What?
That filters this result. So for customers who haven't placed an order, there won't be an entry in the orders table. So orders.ordered will be MNL, it'll be empty.
Got it.
So this where clause filters the results to only show the names of those customers where there's no order ID.
Okay.
So they exist in the customers table, but they have no corresponding record in the orders table.
So it's a really clever way to use left join
It is.
to identify records that don't have a corresponding entry in another table.
Exactly. It really demonstrates the power of SQL in querying data, combining data from multiple tables
Right.
based on specific conditions to really answer very targeted questions about your data.
So this has been a really great overview, just to kind of recap.
Yeah,
So SQL is a standardized language for interacting with relational databases.
it is.
These databases organize data into structured tables.
Yep.
The relationships between the tables are defined using primary and foreign keys.
Yeah.
And then we looked at all the basic commands: create, insert, select, update, delete.
Those are the big ones.
So this really is essential for understanding how so much of our online world works.
It is.
So here's a final thought for you as you go about your day to day.
Okay.
We all use social media. We all use e-commerce, tons of different apps.
Yeah.
All of that is relying on relational databases and SQL.
Yes.
So next time you're using, Instagram or you're buying something on Amazon, think about all of the data that's being managed, the queries that are being run.
Yeah.
And it really highlights how, powerful
It is.
and fundamental,
It is.
but also invisible this technology is.
Absolutely. Yeah.
Thanks for listening.
Thanks for having me.